Here is a good problem. That is, C, line AB of length 3l. When a particle is at a point P, it experiences a force. Here at P is 2mg by L PA bar and mg by L PB bar. It experiences a force at that point P is. Now the problem is, what is a body projected with a velocity 3 root gl at a time of t second. Now the problem is, what are the equilibrium position and what is the time taken by the particle from A to B and what is the speed on reaching B now and the amplitude of the particle. These are the problems. Now say, based on the simple harmonic motion, if the position of this point is to be taken as x from point A, then force at that point in vector form is given by 2mg by Lx is one direction to be taken as, for example, left side positive, and in the direction of B it will be taken as negative. So here the net force is the difference of these two, you can write, and on solving we get F is equal to in the form of 3mg by L x minus L. So here in equilibrium condition net force is equal to 0, hence x is equal to L. The meaning of this point is, particle is at a distance of x means L from A on reaching point P. Next, restoring force we can write, it is the minus of applied force minus of this force, and on solving it is in the form of F minus 3mg is equal to minus kx. Here it will be taken as net force is F dash minus kx. From this comparison, spring constant is 3mg by L, and from this one angular frequency is root of k upon m, that is 3g by L. And from this equation, time period of the particle while complete oscillation is taking, this is 2 pi into root of L by 3g. By applying the velocity of the simple harmonic oscillator, V is equal to omega root of A square minus x square under root. Here by solving we get the value is as from that point, the velocity at that point is 3 into root of g by L, and here omega is from this equation, A to be determined, x is L at the point of A to B. Now the amplitude of simple harmonic oscillator is A is equal to 2L, and remember from point P to B, by applying the same equation, V is equal to omega into root of A square minus x square, that the velocity at point B is, remember, if you take AP is equal to L, then what is going on? This is 2L. If it is L and it is the 2L, so 2L is the amplitude. So P is a point of equilibrium position from this equation. So on reaching from P to B, the velocity will become 0. Now what is the time taken by the particle on reaching from A to B? Here the time taken by the particle on reaching A to B is, see, the time is equal to, for A to P it takes a time of, because velocity or displacement at this point with respect to mean position is A by 2, L means A by 2. So time taken by the simple harmonic oscillator in traveling from mean position to a displacement equal to amplitude, half of amplitude is T by 12, and time taken from P to B is 1/4 of oscillation is T by 4. So here solving we get it is 4T by 12. So the total time on reaching from A to B is T by 3 seconds. It's a good application of this problem. So we will connect with the next problem, a good problem. Thank you.